Hey, what's up guys? Thanks for joining us today on the King of Random. Batteries are everywhere and we use them in all sorts of stuff. And a lot of the time they come with warnings saying to make sure that you dispose of them properly and how they can be dangerous if you misuse them. Well, today we're going to take this group of batteries and we're going to run them through a series of destruction tests to see what happens if you stab them, cut them open, smash them, or even burn them. So let's get started. Not too long ago, I tried using a nail to slightly dent a battery to help balance a homopolar motor. Well, now I'm going to see what happens if I take a nail and drive it as far as I can into the battery, not just denting it on the top. Oh, it's leaking something already. There's liquid coming out of this battery. Well, that's a good start. Let's keep driving the nail and see what keeps happening. I'll be honest, I didn't really think that the nail was going to be able to drive this far into the battery. That is pretty much all the way through it. And it is still leaking. We've got this liquid leaking out, which I believe is potassium hydroxide, which is supposed to be fairly irritating if you get it on your skin. So try and avoid touching this stuff. And our battery is also getting pretty warm. I'm gonna hit it with this little laser thermometer. 120 Fahrenheit. Battery is getting quite hot now. As a comparison, if I take a scan of the block of metal next to it, that's at 65. The battery is at 135, still heating up, pretty warm to the touch. 136. I'm just gonna stand back a little bit, let it go, and see if anything keeps happening to it as it warms up like this. See if I can take an accurate measurement from this far away. It's showing 145 now. Well, if I get closer, it's showing 166. I'm gonna try and pull the nail out. There's a battery with a hole in it. I think it's cooling down a little bit now. Feels kind of oily. Not like really oily, but a little oily. All right, well, I'm gonna try that exact same thing, but I'm gonna drive the nail in from the other side. More oozing liquid. Going in at a weird angle here. Let's see if I can straighten this out. Oh, and since there's a hole, I can now go all the way through. My thermometer is showing that it's up to 100 degrees Fahrenheit. You can watch it just climbing in temperature. Our other battery got up to 166 on here, and now we're only hitting 116, so it's definitely warm, but it's not as hot as the other one. Now I've driven a nail through either end of the battery. I think it's only fair that I try and drive one right through the side. It's warming up again. Just hit 100 degrees Fahrenheit. Oh, something just made a fizzle noise. As the liquid inside the battery is spurting out onto the nail, it's occasionally making a hissing sound. Just past 130 Fahrenheit, 140. The orb hissing and bubbling. Seems to be hovering right around 150 now. And once again, we have a battery with a hole running right through it. Holding it still for a couple seconds, it really does start to heat up in my hand. Well, I would say that being stabbed with a nail is definitely not good for batteries. Now, since it should be a fun way to destroy it and I want a good look at what's inside, I'm gonna take a hacksaw and cut this C-cell battery down in half lengthwise. There's our black liquid oozing out. All right, I've got this black paste just all over the blade of the hacksaw now. Turn this upside down. Keep cutting through it from the other side. Ooh, I think I've got it. Gross. Well, I've got a gooey paste here and a slightly less gooey paste here. Smells a little bit like ammonia. This paste looks like it's full of little metal flecks. I need to do some research and find out what is inside a battery. This rod is coming from the negative terminal, so this rod clearly goes down into this silvery paste. About the consistency of toothpaste, I'd say, maybe a little bit thinner. It's like really, really compacted dirt kind of texture. Now it's just this metal shell. There you go, guys, a C-cell battery. Probably a little bit difficult to fit inside your remote control car at this point. Our next method of destruction might not be quite so eventful, but I've always wondered what would happen if you just took two 9-volt batteries and plugged them into each other and just let them sit. I'm sure you're not supposed to do that, but let's find out why. All right, those are now providing feedback into each other. I'm just gonna check with the thermometer what temperature they're getting to. Let's see if they are warming up a little bit at a time. 75. Ooh, some part of the battery is a lot warmer. That's measuring 85. There's different temperatures, different parts. Parts of it are at about 80 right now. Other parts are over 90. Oh, over 100 Fahrenheit now. That's interesting. One of our batteries is considerably warmer than the other. This battery is only measuring at about 85 right now. But this battery is measuring in at about 105. Curious. The gloves do insulate a little bit, so it's hard to tell for sure. But I think this one does feel warmer. It's warm enough to cook a steak if you like it rare. Next up, we've got a 20-ton shop press, and we're gonna see what happens if we put a couple different types of battery under that and just squish them. We've made contact, now the squishing begins. Ooh, that circle might just bite right into the battery. We've got some stuff oozing out. Good amount of stuff oozing out on the back. All right, I think that's about as flat as this jack is gonna get it. It's pretty squished. I think it actually bounced back a little bit after being squished. You can definitely see some of the innards of it. Now I've got a C-cell battery under here. Let's squish that down and see what happens. It is definitely deforming sideways, so I'm pretty sure it's just gonna pop out in a second. Or it's just gonna burst and squirt liquid really far. That was exciting. Well, now it really is like toothpaste being squeezed out. That is obliterated. Quite completely obliterated. This smushed C-cell battery is probably just as broken as the one we cut in half. That really just oozed out there, kind of like toothpaste at one point. That was fun. Now for our next type of destruction, I'm gonna try hitting a few different types of batteries with a blowtorch. I've got our 9-volt battery, a normal AA battery, and then I also have a lithium AA battery, which does contain lithium and should burn very brightly and possibly with interesting colors. We'll see if it actually burns through to the lithium well enough to ignite it. Not sure if it'll work or not. As you can see, I'm also now wearing a jacket, and that's just for protection in case something burns or shoots hot liquid at me. I just want a little bit more protection. I'm gonna start out with the 9-volt. I am nervous doing this, holding it this close to me. All right, that was a little too nervous just holding that battery like that. So I've now got this system set up so I can just set the torch on the battery, then safely back away. Let's give it a shot. Got a little glowing orange spot. The bottom seems nice and hot, but it doesn't actually look like it's doing too much. Certainly some flames coming out of it. Ooh, oozing out the back. Now it just seems like the whole battery's kind of on fire. All right, let's turn that off for a bit. That's some interesting colors right there. Sort of a bright glowing smoke for a second. That was interesting. And we've got these smaller piles inside. I didn't think this type of battery worked like that. I think each of these is a 1.5 volt battery, and then there's 6 of them. Gives us our 9-volt battery power. Let's try it with our other types of battery and see what happens. Well, it's peeling away the wrapper on the battery pretty instantly. Starting to leak pretty quick. Much faster reaction than the last one, that's for sure. It smells awful too. Ugh. Timber! Let's try our lithium battery. Once again, the outside gets destroyed immediately. Whoa! I think it lit. Okay. And now it's, no, now it lit. Now it lit. That's amazing. That's fantastic. What even just happened? Yeah, look how pink that is. It's magenta colored. It's not a normal fire color. There's still something melting on the back. I don't know what liquid that is that's boiling and bubbling there. Now I just have like this glowing orange, I don't know. It's like glossy on the outside. Inside these lithium batteries, there actually is a strip of lithium metal, and we're gonna see if we can take that out. That's what's causing the bright magenta flames. There we go, that whole thing. So there you have just coils of metal strips inside there, and one of those strips is lithium. Take this whole wad of, there we go. So this one I believe is not our lithium. I don't know exactly what metal it is, probably aluminum. Then here inside our plastic, that is a strip of lithium metal. Very lightweight, like more than aluminum it feels like. This feels super, super light. Also tears very easily. It's really soft. You can see how easily it wrinkles and everything. This feels thicker than aluminum foil, but it's at least as soft, maybe softer. All right, so let's light this little piece of it off. You can see how magenta those flames are. And then when it really ignites, it gets very bright. Look at that, it's melting into our fire brick. Let's see if I can put another piece of it on top of it. Yep. It's really bright. Kind of hurts to look at, it's so bright. And it's like the smoke is being lit up by the heat of it or something. That's pretty crazy. There you have it. We've just destroyed a whole bunch of batteries in a whole bunch of ways. We stabbed, cut, smashed, and burned our batteries to see what happens. I can't say I really recommend doing this because then you don't have your batteries anymore, although burning the lithium batteries did look pretty cool. We found that inside the batteries was a silvery paste and a black clay-like substance. Cutting the battery in half really let us see the insides pretty well. A nail driven through a battery caused a lot of leakage, and I'm sure the batteries don't work at all anymore. And lighting the batteries on fire had different effects based on what type of battery they were. Regular batteries just sort of burned up and maybe oozed out some of their liquid, and the lithium batteries popped and then burned a bright magenta color. This really satisfied a lot of curiosity I've had since I was a child and was told that you had to make sure you don't use damaged or dented batteries because it could cause problems. Well, now I've seen some of those problems that can happen if you take them to an extreme. I've really enjoyed this random destruction of these batteries. I hope you've had a good time. Thanks for joining us for this video, and we'll see you in the next one. Talk to you then. Franken battery. Smells like rotten eggs. I don't think this one's actually going to be very exciting. I think it's just, yep, they're ruining each other.
Hey guys, if you are on Twitter, come follow me on Twitter at The King of Random. It's a great place to connect with me one-on-one. That's all I'm going to say about that, because if you want to, you will, and if you don't, you won't. So I will see you there. Or maybe I won't.